Good evening guys, welcome back to Telepedia Tutorials. The last video I posted, we talked about molten and aqueous electrolysis, the key differences, and everything was explained in the best way possible. And we looked into the big question as regards to aqueous electrolysis, which is which of the ions will discharge at the anode and cathode. I believe you know where that question is coming from. If you don't know, you can go back and recheck the video to fully understand. And we said that these are the three factors that influence preferential discharge of ions. So from here, we'll be looking deeply into some questions as regards to molten electrolysis, and later on we can come back to aqueous electrolysis, where we are going to enumerate on these three factors. Now, coming back to molten electrolysis, we have said that this is the electrolysis that occurs in the absence of water, in which we are going to have only one cation and one anion. So we are now going to look into some examples of ionic equations involving molten electrolysis that express what is going to be discharged at the respective anode and cathode. Now, one of the most important uses of molten electrolysis is extraction and purification of metals. Due to electrolysis is very expensive, some of the commonest metal we use electrolysis to extract are the highly reactive metals and the group 1, group 2, and group 3. Examples are lithium, sodium, calcium, magnesium, and aluminium. Other metals that are less reactive than these 5 metals listed here are usually extracted by what we call chemical reduction process using carbon. Examples of metals that can be extracted by chemical reduction process is metal coming from hematite, which is of iron, and metal coming from galena, which is of lead. So with that said, please note all these points are just enumerated because they do ask it both in JAMB and WAEC. Now, the ionic equation for molten electrolysis is highly simplified. Why is it simplified? Since we're having one cation and one anion, we're going to see that the cation will move to the cathode, where it is going to undergo reduction, which is gain of electron, while the anion will move to the anode, where it is going to undergo oxidation, which is loss of electron. The amount of electron an element is going to gain corresponds to its valency. So as magnesium has 2+, it's going to gain 2 electrons. As chloride ion has -1, it's going to lose 1 electron. And other balancing can determine the final number of electrons lost. So this solution is solution to question number 2, which is they say using equations express what is discharged at the anode and cathode during the electrolysis of sodium chloride, magnesium chloride, bauxite, hematite, galena, fluorspar. So we're moving to solution 2. We write the ionization equation for magnesium chloride. I believe by now you know how to write chemical formulas of chemical compounds. So this is the formula for magnesium chloride, and this is the formula for sodium chloride. I believe you know how it came about. So when magnesium chloride undergoes ionization, it's going to form magnesium cation and chloride anion. Magnesium has a valency of 2+, chloride has a valency of -1. We balance the chlorine in the left side and right side by putting 2 here. So magnesium, which is the cation, moves to the cathode. That is going to lead to the cathodic half equation. At cathode, as I explained the other time, ions gain electron. Gain electron means that they undergo reduction. So this is magnesium cation, gaining 2 electrons, which corresponds to the number of its valency, to now be discharged as magnesium metal. Please note that in this form, it is existing as a neutral element. It is not charged. In the left hand side, it is existing as an ion. In the right hand side, it is existing as a neutral element, or we say it is existing as a metal. As we move down to the anodic, where the chloride migrates to the what? Anode. We are going to write the anodic half equation, where chloride ion is losing 1 electron to form chlorine gas. When we balance the number of chlorine in the left and the right, this is going to lead to 2 chloride ion losing 1 electron each, which makes it 2 electrons to form what? Chlorine gas. Now when we bring this -2 electron across, we are going to, it turns to what? Plus. So in conclusion, based on this equation, we can say that when molten magnesium chloride undergoes electrolysis, magnesium metal will be discharged at the cathode, while chlorine gas will be discharged at the what? Anode. In some cases, you can be asked to write summary or combined ionic equations. We are going to look into that as we move on with electrolysis of molten bauxite.